Welcome to Experimental Design, Thinking It Through Demonstration Lab Part 2. Hopefully you have a document open on Classroom or you picked up one in class to fill in the blank. So you took your hand at planning out and deciding on some things related to Part 1, related to the same question. Does use of commercial fertilizer have a significant effect on garden plant growth? So first off, did you identify the independent and dependent variable correctly? So to fill in the blank, I hope you would fill in with fertilizer amount for the independent variable. That's what we're testing with our experiment. And we're trying to see if it has an impact on the dependent variable, in this case, which is plant growth. We're measuring plant growth. So thinking of the decisions that you would have to make for such an experiment, these are the decisions I made. So again, follow along, fill in the blanks, and turn in this to complete this lab option for quarter 3. All right, so what should you grow and what reasons do you have for the plants you chose? Well, here's a picture of the plants I chose. Convenience sampling was a factor for deciding on seeds based on a collection I've had over the past several years that I have available now and won't add expense. So I already have them, I don't need to purchase more. Another factor to consider is variety. Thinking maybe not all plants respond to commercial fertilizer in the same way. I also want to use plants that grow fairly quickly but not extremely large right away so they can grow indoor in restricted space, which we have. It also makes sense to grow something I like to eat for food too. Factoring in the above, I decided on cilantro, Swiss chard, sweet basil, and cherry bell radish seeds to plant. Even though I don't enjoy eating radishes like my dad, they do have, typo there, the shortest growing time to maturity. So what soil type will I use? How will I decide? Give your reasoning. I was out of indoor growing soil for indoor planting, and it's still too cold and frozen outside to dig up my own black dirt from around home, which would be free. So I need some soil. So at Menards, I came across ProMix potting soil on sale. It was in the main part of the store, so not ice cold, that was another draw for choosing this kind. I've used ProMix potting soil before and they have worked well. The package said it was a blend for variety of garden plants. So if I'm growing different types of plants, that would be good for our experiment. So it's meant for growing indoor and outdoor. So then these can be transplanted. It has peat moss blend within it, or a peat moss blend in the soil, which helps retain moisture. This might be helpful on the weekends when I can't get in and water the plants too much during that time. So that's a picture of the soil that I got. What kind of containers will you use? How many containers? How many plants? First, I want to consider sample size, trying to increase accuracy of my results by growing as many plants as I can. This helps account for individual differences between plants. We also have limited counter and window space for keeping the plants, so having smaller, compact starter pots will be better for our space restrictions. As such, I chose to use Burpee Super Seed pop-out reusable seed starting trays. I used a set last year and they worked well. Each tray has 36 cells or compartments for starting a seed. It's a tray within a tray, allowing for drainage from the top one and water collecting tray underneath to keep the countertops from filling with water, but the plant's soil will drain sufficiently to avoid saturation and seed rot, which students have had in the past. If I get 2 trays for each test group, that could be over 70 plants for each treatment, enough data to run statistical tests on. That means planting 72 times 3 seeds, or 216 seeds. I would like to have, or I would have liked to get 100 samples per test group, but time, space, and money are limit that. Materials were adding up cost-wise, and Menards did not have more of the trays I wanted, but I didn't want to make a trip elsewhere based on time and gas cost considerations. Measuring all the plants will take time too, so without students' help, 400 plants might be too much for me to manage. Counter or window space also limit getting too many more trays started. So how many test groups will you set up for your experiment? Explain your choice, which commercial fertilizer will you use, and why? Well, I forgot to take a picture of our Miracle-Gro, but most people are familiar with what Miracle-Gro looks like. And so I chose to use Miracle-Gro commercial powdered fertilizer because I have it on hand from last year, and it mixes easily with water, which we have accessible in our lab sinks. It's also a popular brand that people are familiar with. On the package, it has a recommendation for how much concentrated mix the fertilizer solution should be. How concentrated to mix the fertilizer solution. Now, I was thinking it's the company's best interest to have you use up their product sooner than later and have to buy more to replace it. So I wondered if you could get equal results from growth in plants if you only use half the recommended amount of fertilizer. As a controlled experiment, we also want to grow plants without any added commercial fertilizer. This would be our control group. It could be interesting to see if doubling the amount of fertilizer helps plants grow even more, but that would double fertilizer costs for my garden anyway, and I'm not willing to do that. So in the picture here, you see 2 times fertilizer. We're going to scrap that. We're just going to do recommended fertilizer amount, half recommended fertilizer, and no fertilizer for our control group. So for this experiment, I'll have 3 test groups. Plants grown with no added Miracle-Gro, plants with half the amount of recommended fertilizer, and plants with the recommended fertilizer amount. So where will we keep them? Well, you can kind of see our space, and you're familiar with that already. The test groups will be grown near the classroom windows, which are west-facing, trays on the countertops, and making use of natural light. The trays need to rotate counter location every 3 days to give each test group a chance to grow under the sunniest position on the counter. This rotation is an attempt to keep the lighting the same for each test group. As plants grow in height, trays will also be rotated 180 degrees to counteract a phenomenon known as phototropism. This is where plants respond to grow toward a light source. In this case, it'll be towards the window. If spacing allows it, I may set up a group of plants, all 3 test groups, under artificial light too. These will be easier to keep the light levels consistent. What will the watering schedule look like? If the plants have the same soil type and growing conditions, including drainage, they should need watering on the same schedule. In the past, I've used a finger test to determine watering needs. This is where you touch the soil where the plants/seeds are growing, and if dirt sticks to my finger, then it has enough water, and I don't need to add. If my finger does not get dirt on it, then I can water the plants. My system of watering will be routine, done the same for each test group, pouring slowly and consistently from the same size watering container along each tray row until each plant gets roughly the same amount of water. Ideally, I would give each plant the exact same amount of water, but that would be too time consuming. What will you measure on your plants to determine better or worse plant growth? What are all possible kinds of measurements you could consider? Which one would you choose? Explain why. Well, a lot of times people like to measure height. Measuring plant height changes over time is interesting to observe, but very challenging to keep track of. Lots of measurements are involved. I've had better luck using estimated leaf surface area upon completion of the experiment. That way you measure plant growth only once to see if at the end of your experiment, again, restricted by school year and plants outgrowing their containers, there are differences in their leaf growth over the same amount of time based on their differing fertilizer amounts. With this approach, you can collect your data when it's most ideal, not having to track hundreds of plants multiple times over the course of the experiment. So for this measurement, I will need a small centimeter ruler, data tables, or paper on a clipboard, and a pencil. I've also in the past used a calculator to help me with my estimation factoring, because there's actually a process for estimating the leaf surface area, and I would have to share that a little bit later on. So hopefully you're able to fill in the blanks and complete the lab assignment.